students, we'll move to the next lesson of physics, that is force and pressure. So about force you have studied in your earlier classes, maybe in 5th standard, 6th standard as well as in 7th standard. What is force? Basically, force is nothing but it is a push or pull on an object. Push or pull on an object we call as force. So when you push an object, object moves. When you pull an object, object moves. So we are exerting force by pushing or pulling an object. So basically or in general we can say that force is a push or pull on an object. When you are moving an object, when you are pushing an object or when you are pulling an object or when you are lifting an object, can you see the force? So this is an important question. Can you see the force when pushing an object or pulling an object? Is it possible? Can we see the force? It is impossible. We cannot see the force. For example, if this duster is not moving, it is in the stationary position. If I push this duster, if I apply force on this duster, if I push this duster starts moving. But can you see the force here? I cannot see the force, but what I can see, the movement of the duster, that is nothing but effect of force. So when you apply force on any object, we cannot see the forces, but we can see only the effects of forces. So first we'll study what are the effects of forces. What are the effects of forces? So the first effect of force, the first one. Force can make a stationary object to move. Force can move an stationary object. Stationary object. Stationary object in the sense, object which is not moving. Object which is not moving, I can make it to move by applying force. I can take the same example. This duster, it is in the stationary position now. So if I push this duster, if I apply force on the duster starts moving. So a stationary body starts moving by applying the force. This is one of the effects of force. So force can make a stationary body move. It moves an stationary body. Object which is at rest position, by applying force we can make it to move. For example, if you start a bus, so bus in the beginning which is in the stationary position, when you start the bus starts moving by applying force. This is one of the effects of force. Force can move an stationary object. An object which is not moving, we can make it to move by applying the force. We'll go to the second effect. What is the second effect of force? Force stops moving object. Object which is moving, we can stop that motion by applying the force. For example, while playing cricket match, if the fielder catches the ball, what happens? What happens to the ball? Ball suddenly stops. The movement of the ball suddenly stops. Moving ball suddenly stops. So, a moving body can be stopped by applying the force. For example, one more example I can give. So, in a vehicle or when the driver applies the brake suddenly, applying the brake is nothing but applying the force. When the driver applies brake suddenly, bus stops or a vehicle stops. It suddenly comes to the stationary position. So, force can stop a moving object. We can stop a moving object. We can make a moving object to come to the stationary position by applying force. This is another effect of force. So, force can make a stationary object to move. It can make a stationary body to move. Or force can make or force can stop the moving object. This is second effect of force. But in this case also, I cannot see the force. I can see only the effect of force. So what is the effect of force here? Stopping. So object which is moving, it comes to the stationary position. That is the It is possible to change the direction of the object by applying force. Example. What example you can give? You take the example of a cricket match. So when the batsman hits the ball, what happens? The direction of the ball changes. When the batsman hits the ball, the direction of the ball changes. Batsman applies force on the ball. Because of that, direction of the ball changes. So in the vehicle, direction can be changed. Driver applies the force to change the direction of the moving body. So direction of any object can be changed by applying force. By applying force, we can change the direction of the moving object. And also, we can change the shape of an object. It is possible to change the shape of an object by applying force. Example, take a lemon. Squeeze the lemon. What happens? Shape of the lemon changes. Take a rubber ball. Take a rubber ball and apply force on the rubber ball. When you apply force on the rubber ball, the shape of the rubber ball changes. So force can be used to change the shape of an object. So these are the effects of forces which we can see in our day-to-day life. In our day-to-day life, the activities which we do in our day-to-day life, in that activities we cannot see the force. We apply the force, but we cannot see the force. We can see the effects of forces. The changes takes place because of by application of force that is observable, that we can see. So what are the effects of forces? Using the force, we can change, we can make a stationary body to move. It is possible to move the stationary body by applying the force. We can make a moving body come to the stationary position, or it is possible to stop a moving body. Object can be stopped by applying the force. It is possible to change it. It is possible to increase the speed, or it is possible to decrease the speed of an object by applying the force. And also, force is used to change the direction of the moving body. To change the direction, force is important. We have to apply the force. And also, it is used to change the shape of the object. To change the shape of a body, to change the shape of an object, we have to apply the force. So these we call as effects of forces. In our day-to-day life, we cannot see the force, but we can see the effects of forces. So these are called effects of forces. So we have seen the various effects of forces. So by applying force, the various effects, the various changes takes place in an object that we have already studied. But the question is, when does this force come into play? When does the force come into play? We take the example. Consider the same example. So this duster, it is in the stationary position. To make this duster to move, I have to apply the force on the duster, so the duster starts moving. To make the duster to move, this stationary duster starts moving. If I push the duster, if I apply the force on the duster, pushing is nothing but I am applying force on the duster, so that duster moves. Suppose if I say, if I hold this duster, I am holding the duster and I say, duster starts move. If I say like this, whether duster is moving, duster cannot move. So what I have to do? I have to apply the force. How I have to apply the force? I have to touch the duster as well as I have to push this duster. By touching the duster, I have to push, I have to apply the force. So you can see, there is an interaction between my fingers or my hand as well as the surface of the duster. There is interaction. If I touch this duster and if I apply the force, duster starts moving. So that effect of force, that motion can be seen when there is interaction Then the force come into play. For example, if you want to shift a desk, if you want to shift a desk or a bench, or if you want to shift a table, what you have to do? You have to touch that table, you have to push the table. Because of that, because of interaction between your hand and the surface of the table, table starts moving. To move a bench, what you have to do? Either you have to lift the bench or you have to push the bench so that bench moves. To open the door, what you have to do? You have to touch that door and you have to push the door so that door moves. So what you can see here in these examples, it is very clear that is there should be an interaction. Two objects must interact. There should be an interaction between the two objects so that we can see the effect of force. Because of that, force come into play. So force come into play only when there should be at least two objects. There may be more than two objects, but at least two objects, and those two objects should interact with each other. Then force come into play. We can say that force come into play. Take an example. Take an example of lifting a box. Consider here there is a box. This is a box with full of books. Box with full of books. Consider a person A. He is applying some force on this box. He is applying some force on this box and he wants to shift this box. So consider he applies a force of about 10 Newton. Newton is the SI unit of force. About that you will study in detail in next class, that is in the 9th standard. About that you will study about magnitude of the force. Consider now he is applying some force and I am taking this force as 10 Newton of force he is applying and he wants to shift this box. But this force is not enough to shift the box because this box is full of some books or many things. So this box is very heavy. So because that box is very heavy, the force applied by this person is not enough to shift this box. Now there is one more person. Consider one more person is here. He is also applying about 10 Newton force. He is applying about 10 Newton force. This one is pushing the box in this direction. This one is pushing the box in this direction. See the direction. This direction, this direction. That is, this is towards the right, this is towards the left. He is also applying 10 Newton force. This boy is also applying B. This is person A. Also applying 10 Newton of force, but he is applying in the right direction. This person is applying in the left direction. So what is the direction of the forces? Direction of the forces opposite to each other. They both are pushing the box. Both are pushing the box, but this one is pushing the box in one direction. Second person is pushing the box in the opposite direction of that of the first person. Both are applying same amount of force. Whether this box moves, whether the box moves, box is not moving. Why box is not moving? Because same amount of forces applied opposite to each other. The same amount of forces applied opposite to each other. This direction 10 Newton of force, in the opposite direction 10 Newton of force. Then how much force is applied on this box? What is the total force applied on the box? The total force applied on the box is 0 Newton. Why it is 0 Newton? 10 Newton minus 10 Newton is 0 Newton. So no force is applied on the box. If a person A applies 10 Newton of force in one direction, he starts pushing in one direction. With the same amount of force, a person B starts pushing the box in the opposite direction. Then this box is not moving at all because the total amount of the total force acts on the box will be 0. Resultant force is 0. When the forces are applied in the opposite direction, to find the total force, when the two forces act in the opposite direction, to find the net force acting on the box, the net force acting on the object, to find that we have to take the difference. Difference between two forces gives the net force or the total force acts on the box. In another way, we can to move this box, what we can do? So the same box with full of books and many things. If person A, he is pushing in this direction with the 10 Newton of force, and one more person, that is person B, he is also pushing. He is applying a 10 Newton of force in the same direction. So 10 Newton of force of person A, 10 Newton of force of person B, both are applied in the same direction. Two persons come together, and if they start pushing the object, then the object moves. Why object moves? Because the force which acts on this object, first person's 10 Newton force, second person's 10 Newton force. Together 10 plus 10, 20 Newton force. A large force acts on the body. Because of that, object starts moving. For example, if you want to shift, if you want to push a large cupboard, one person is not enough. 2-3 persons, we come together and we try to push that. So when we try to push that, that object moves, because the resultant force on the object, if two or more forces acting on the object, if the forces applied on the object in the same direction, to find the total force, we have to add the individual forces. So we have to add the forces. So how much force is applied on this box? 20 Newton force. First person's 10 Newton force, second person's 10 Newton force. Together 20 Newton force applied on the object. Why? Because force is applied in the same direction. So this is the common sense. When you are shifting, when you are pushing, when you are displacing any object, huge thing, if one person is pushing that, if his force is not enough, what we have to do? 2-3 persons come together and they start pushing. So when 2-3 persons start pushing any big thing, any heavy object, so all the forces applied on that object gets added, so that object moves. Suppose if one object is applying force in one direction, another object is applying force in another direction. So the total force on the object will be, to find the total force on the object, we have to take the difference. I will give one more example. Consider here there is a big rock. Here there is a big rock. Consider there is a big rock. So a person A applies about 20 Newton of force on this big rock. A person A applies 20 Newton of force on this big rock, and there is one more person here. He is applying about 30 Newton of force on this big rock. He is pushing in this direction. This one is pushing in opposite direction. So how much force acts upon this object? How much force acts upon this rock? This one is 10 Newton force is applying. He is applying 30 Newton of force. That is not together. Total force, the net force applied on this rock will be 30 minus 20. That is 10 acting in the same direction. Consider 20 Newton of force acting here. One more person, how much? 30 Newton of force acting in the same direction. Then what is the net force in this case? Net force will be 20 plus 30, which is equal to 50 Newton. So that is the meaning of this statement. When the force is applied on an object in the same direction, the net force acting on the object, the total force acting on the object can be calculated by adding. When you add the forces, we get the force applied on the object. Suppose if two forces are acting in the opposite direction, if the two forces are in opposite direction, then the net force is the difference between the two forces. Difference between two forces gives net force. So by this way we can find out the net force or the total force acting on an object. We can take the example of a tug of war game. So you are very good about this tug of war game. So what happens in tug of war game? There will be two teams and equal number of members in both the teams, and they try to pull the rope. They try to pull a rope. So what is the object here? Consider two teams, team A, team B. This is the rope. Applying force, this team A applying force on this rope, team B applying force on this rope, same rope, but the direction will be in the opposite. So this one applying force in this direction, they try to, these team A members try to pull the rope to their side, team B try to pull the rope to their side. So the force is applied on the same rope. Consider 5 members in team A, 5 members in team B. 5 members in team A and 5 members in team B. If both the teams exert same force on the rope, if both the teams are applying same force on the rope, whether the rope moves in any direction, rope is not moving in any direction. Why? Why? Because the net force acting on the net force acting on this rope will be 0. The total force acting on the rope, same amount of forces applying same force on the rope, then the rope is not moving because the total force, net force acting on the rope will be 0. We say the forces are balanced. Forces gets balanced. Forces are balanced forces. So we cannot see any effect of force. This rope is not moving in any direction. Suppose team A, the members of team A, if they apply more force on the rope than the team B, if the team A members apply more force on the rope than the team B, then this rope starts moving which direction? Towards team A. This rope starts moving towards team A. Why? Because here more force, here less force. So forces are not balanced. Forces are unbalanced. Forces are unbalanced. If the forces are unbalanced, this rope starts moving in the direction where we are applying more force. So when the forces are unbalanced, we can see the effect of force. What is the effect of force here? So this rope starts moving in one direction. So team A wins the game. Team A wins the game. In the tug of war game, team A will be the winner. That is the effect of force. So to see the effect of force, as I explained various effects of forces, to see any effect of force, we have to cannot see the effect of force. So applied force should be unbalanced. If the net force acting on the object is unbalanced, then the object starts moving, object changes its direction. If the applied force is balanced, we cannot see any effect of force. To see the effect of force, the force should be balanced. The force applied on the object should be balanced. So here the net force can be calculated. If the number of forces are acting in the same direction, so we have to add the forces so that we can get no total force. If the forces acting in the opposite direction, then we have to find the total force, we have to find the difference between the individual forces so that we can get the total force acting on the object.